Hello, my name is Brian Willis. I'm a technical solutions engineer here at Avnet, and I am one of the Azure Sphere experts on the Avnet team. Today I'm going to do a quick video walkthrough of the onsemi RSL10 demo that we've created and have published on GitHub. So the first thing I'm going to do is I'm going to show you the hardware and how to assemble the hardware. We're going to clone the GitHub repo. We're going to open up the RSL10 project. We're going to configure that project to connect to my IoTHub on Azure. And then we'll build and run the demo and exercise the demo. And then we've got an Avnet IoT Connect sales demo that the application can connect to. And so I'm going to configure my device to do an over-the-air update to pick up the application version that connects to the IoT Connect demo, and then we'll connect to the Avnet IoT Connect demo and exercise it. So let's look at the hardware. So this is the kit. So I've got an Avnet Azure Sphere starter kit here. This is a Rev 1 board, and I've modified this board by soldering on a 2x6 right angle connector there. I've got an Avnet BLE PMOD, and I've got an RSL10 development device and the battery for it. So let's go take a look at the GitHub repo real quick. So this is the Avnet Azure Sphere Samples GitHub repository. And if we drill down into the samples folder here, you'll see that we've published a lot of different Azure Sphere samples. But the one we're going to talk about today is this Avnet RSL10 sensor demo. And if we open up this sample project, I've got a little bit of information here. It tells you how to update the device. The BLE PMOD needs to be updated with newer firmware, and there's a software application that I've written that needs to be loaded on there. So all the detail for that is there. But the required hardware is the Avnet starter kit. There's the Avnet starter kit. If you need to read more information about that, I will provide this link in the description below. And then you need an Avnet BLE PMOD. So the PMOD has a layered BL654 module that has an integrated antenna designed around the Nordic NRF 52840. So this is a nice little add-on for the starter kit. Communicates to the starter kit over a UART, and we can put custom software on here, and that's what I've done for this demo. And then the last thing you're going to need is RSL10 Sense GEVK. So this is an evaluation kit from onsemi that contains their RSL10 device on it. So you need all of those things. And so let's go ahead and we're going to clone this project. So to clone the project, I'm just going to go back to the top level. And when you clone this, you need to clone the entire project because this hardware definitions directory is referenced by all the different samples. So you need to get the entire repo. And to do that, I can just hit the clone button there to copy that URL. And then I'll clone it into the Demo 2 folder. So that's going to take less than a minute, more than likely. And so I will open up. I'm going to use Visual Studio Code for this demo. And then I'm going to go and I'm going to drill down into that directory structure to the Avnet RSL10 sensor folder. Select that folder. I need to update the app manifest JSON file with specifics for my IoT hub. So I need to give it a scope ID for my DPS. I need to add my host name to the allowed connections list, and then I need to update the device authentication field with the GUID for my Azure Sphere tenant. So I'm just going to pause the video and I'm going to do that real quick. Okay, I've updated my app manifest JSON file. So the next thing is I need to go ahead and assemble this. So I'm going to power down my device, and I'm going to just connect the the BLE PMOD device into my right angle connector, and I'm going to go ahead and power up my RSL10 as well. So the RSL10, when it powers up, you should be able to see a green blinking LED. It's just kind of barely visible in the video. And then I'll go ahead and power it up. Now, so my device, I believe it's already in development mode, but actually I'm not sure, so I'm just going to do that. I'm going to put it into development mode so that I can sideload code and use the debugger from Visual Studio Code or Visual Studio. And then the next thing I'm going to do is I'm going to just make sure it's got a Wi-Fi connection on it as well. Okay. I'll list all the Wi-Fi connections that are configured on the device, and there's none, so let's do a Wi-Fi add. SSID is IoT Demo, and the passphrase is Demo 2001. And I like the targeted scan option. Just make sure that connects to my Wi-Fi access point. And there it's connected. Okay, so now I'm going to go ahead and I'm going to run the application. And from Visual Studio Code, all I have to do is hit the F5 key, and it will build my application and sideload it onto my device. Now, one of the nice features that's implemented in this application is that I use the RGB LED to show connectivity status. So the application's starting up. First it turned red for a second, but it has a Wi-Fi connection, so it turned green because the Wi-Fi is there. And then when the IoT Hub connection is completed, it turns blue. So blue LED means that I have a connection to my IoT Hub. And so what's happening right now is the RSL10 device is just broadcasting data. The BLE PMOD firmware is reading that data and sending it as UART data over to the Azure Sphere application. And the Azure Sphere application is getting that data and it's parsing it, and it's creating telemetry and sending that telemetry up. So we can see here it's sending telemetry. It's sending the address of the device, its current RSSI reading, the temperature, the humidity, and the pressure, and the light is 0. I've got an older RSL10 dev kit. It does not have the light sensor on there. That's why that's reading 0. And it's also sending up the battery level, 2.92 volts. And so it's just going to keep broadcasting that, and my application is just going to keep catching that. The other thing we can do is we can look at the Azure IoT Explorer. So this is an application utility that Microsoft provides, and I've got it connected up to my IoT Hub where my device is, And if I go look at my device, which is this B7 device, I can monitor the telemetry at the IoT hub. And so what we should see is as the application sends the telemetry up, we're going to see the telemetry hit the IoT hub, and there's two messages, right? So there's the temperature and humidity, and then the battery level. So that's all working fine. So another nice feature of this demo is that we can require that the RSL10 device be authorized to connect to the application. Or I guess a better way to put it is be authorized to process data from the RSL10, because it's going to catch the RSL10 data no matter what. So I'm going to stop this application and just show you how that's done. So the way we're going to do that is we're going to enable this build flag called require authorization. And so now if I run this application, I'm going to hit the F5 key again. We're going to see that the application is going to start and it's going to connect to the IoT hub just like it did before. But now we're going to see that when it receives that RSL10 data, that message from the RSL10 device through the Avnet BLEP mod, that it's going to reject the data because it has not been authorized, and it's going to tell us what the MAC address is. So let's see that happen. So the device is going to connect to the IoT hub. There it is. And notice it says device 3E blah 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 is not authorized, discarding message data. And then it tells us that to authorize the device, we can add its MAC address in one of the IoT hub device twin called authorize MAC. And so let me show you that real quick. So I'm going to copy authorize MAC. And if I go back to my Azure IoT Explorer, I'm in my device and I go to device twin. This is going to show me the device twin in the IoT hub. And under desired properties, I can add a new property called authorized MAC 1. So that's my key. And for the value, I'm going to give it the MAC address of my device as a string. Make sure I have properly formatted JSON. And then I'm going to go ahead and save that. And when I save that, what we're going to see is we're going to see the application catch that message and update a data structure. And then the next time that the message comes in, we're going to accept it. So here we go. So I'm going to say save. And there we receive the update, the device update, and we sent back a reported state, and then we added a new device to the list at index 0, and then the next time we receive data from the RSL10, it's going to send it up as telemetry. And there it is. So so pretty slick, right? Nice little control feature there. And if we look at the device twin implementation for this application and look at the twin table that defines all the different device twins that this application supports, we can see that the application supports up to 10 different RSL10 MAC addresses. So if you had a deployment where you wanted to, you had a bunch of RSL10s deployed in an area, and you had, multiple Azure Sphere devices managing those items, you could authorize, the MACs on specific Azure Sphere devices so that they only manage the devices, the RSL10 devices that you wanted them to. We can also turn that required RSL authorization flag on and off from the cloud as well. So anyway, so that's a quick demo of the application and some of its capabilities. So the next thing I want to do is I'll stop the application, and I'm going to configure the device to get an over-the-air update from a specific product device group that I've created to manage a fleet of these Azure Sphere RSL10 demos that we have for our sales team. So let me find the details for that and I'll be right back. So the way I update my device to add it to that device group is I use the AZSphere device enable cloud test command. So that's one way to do it. You can also just do a device update and provide the MAC address, but if this will work for what I need to do. Not sure why it gave the carrots there. And so we can see that it's removing all the applications from the device. It's also removing the GDB debugger from the device because I was just in enable development mode. And then if we look at the device itself, we're going to see that the application is no longer on there because that RGB LED is not lit at all. So I know my application is not on there. But what's happening right now is that my device should be receiving the over-the-air update. There it did, and it started the application. I've got a green LED because it's got a Wi-Fi connection, and it should turn blue as soon as it authenticates to the IoT Hub. And there it turned blue. So now my device is connected to the IoT Hub for the Avnet IoT Connect sales demo, and it is capturing that RSL10 data through the Avnet BLEP mod, and the application is parsing that data and sending it up as telemetry. So I showed you the telemetry at the IoT Hub, but now I'm going to show you the RSL10 demo and show you how we present that data in a nice user interface. So now I want to show you an IoT Connect demo that the SoftWeb team has put together to showcase this RSL10 solution. The demo that I showed you up to this point is an Azure Sphere starter kit with an Avnet BLEP mod with an RSL10 sensor that you can buy all those things and you can put this demo together and you can use the project that I showed you on GitHub, and you can use that and extend it any way you want for your own user application or scenario. But what I'm going to show you now is an IoT Connect IoT dashboard and system that the SoftWeb team has put together. And so when I open up the dashboard, the first thing I get is I get a graphical view of all the devices that are in this demo. So you can see there's about 260 of them all around the world. And I can zoom in on this map and I can go find a specific device. So this is my device. I'm just outside of Wilmington, North Carolina. So I can click in here, and this is going to bring me to the dashboard for my specific device. And I can see that all the telemetry data that my device is sending up is displayed, right? We should be able to see this changing in real time, right? So the RSSI is changing as that telemetry data is sent up. And there's historical data there as well. So I've only got about a day and a half of historical data, but if you had more, it would, of course, be populated on those graphs. So this is one way that IoT Connect can present data in this custom dashboard. But we've also created some user experiences, and I just kind of want to walk you through each of those. And so let me just explain what we're looking at here. So in this graphical representation of, it looks like an office environment, I've got this box here represents my gateway, or in my case this is an Azure Sphere starter kit with my Avnet BLEP mod. This icon here represents an asset, and so in my case this is my RSL10 evaluation kit. And over here in this box we can see that we have the current RSSI, so this is the value that my device is currently reading from that RSL10 Bluetooth signal, and we have a threshold of 65. So if I move my device to another place in my office here, so I'm just going to move it across my desk, we should see this RSSI value change, and we should see the device relocate from this part of the room to this part of the room, so a different zone. right? And so similarly, I can move it back over close to my gateway, and we should see it move back. So another nice feature for asset tracking is that the RSL10 evaluation kit actually has an accelerometer built into it as well. So I can trigger a G-force event by just tapping my device on my desk. So there we can see that the impact was detected. This asset could be like some sensitive medical equipment on a cart, or anything that you can think of really that you want to track based on zone, and maybe you want to know about impacts if impacts happen to it, so you can inspect it if something like that happened. So in the next user experience, we've placed static people in a room who would be wearing an ID badge featuring the RSL10. So in this graphic, the people in red are the static people. They're not going to move. And then we've got a person who can move, and that's this worker in green. And so here again, we have our gateway represented here. And so this would be my Avnet starter kit with an Avnet BLE mod. And then the worker in the green shirt here is represented by my RSL10 evaluation kit. And you can see here that what we do is we can track when we're close to one of the other workers, and then we keep a timer on it. So we've been next to person 1 for 54 seconds now. And we've got these thresholds again. So if I take my device and I move it further away from my starter kit, we're going to see that the person's going to move, and now we start a timer here, and we're going to detect, we're going to track how long we've been in close proximity with this other person, and then at 30 seconds we're going to throw an alarm. And what's one of the really nice features with IoT Connect is that it's built on Azure, and the IoT Connect team has put in hooks to generate events and alarms. And so, for instance, when we get this alarm, worker standing too close to person number 4, we can send an email, we can update a database entry, we can start some kind of an automated workflow, we could sound an alarm. And then the last experience here is a demo of an industrial information push. So imagine that we've got an industrial conveyor belt controller, and it's a very complex panel with lots of knobs and buttons and displays and alarms and things like that. And not everybody's trained on this piece of equipment, or maybe not trained to the level that you would like them to be. So they could be carrying around an iPad or some kind of a tablet, and when they get close to this piece of machinery, it can bring up some information on their display. So right now my RSL10 is far away from my starter kit. So I'm going to move it closer to my starter kit. So now it's closer. And what we see is that as we detect that we're closer to the machine, we can bring up a picture of this controller, and then we can have some informational flyouts, right? So this is a very basic example, but this could be complex inputs, even a phone number to call if there's an alarm or anything like that. So that concludes the demo. Hopefully you've learned a little bit about Azure Sphere. You've learned that there is an example application that you could leverage for your own use if you wanted to. And then I've shown you a few ways that Avnet has leveraged that example to show the different user experiences that I just showed you. I've been using IoT Connect for a little over a year now, and I find it to be a very flexible and responsive system, much more responsive than other cloud solutions that I've used. And since it's built on Azure, the sky's the limit as to what you can do. And the software team that develops the IoT Connect platform, they have the expertise and the skills to help you build out any kind of IoT platform that you need for your business. Thank you for your time.